Okay, this is a video to go over exercises 2A, in which we're going to build a basic tune-based step sequencer. So it develops the tutorial we've looked at where you're building a kind of beat-based step sequencer that triggers general MIDI percussion sounds. We start off with a very similar kind of model to what we were working with last time. You've got a metro which is outputting 200 at 200 millisecond intervals with a toggled start it and stop it and a number box to control the speed of the metro. You've got a counter object which is counting pulses from the metro, and notice that we are operating between numbers 0 and 7, and this is because computers recognize the number 0 as being a value. So to have 8 values, whenever it counts, it starts from the number 0. We've got a select object which is recognizing the numbers that counter is spitting out, and again these start at 0, so when counter outputs is 0, select recognizes it, and because it's in the first argument in a list of 8, then it spits out of the first outlet. When counter outputs a 1, counter recognises that 1, so it looks through its list of numbers and identifies that there is a 1 in there and that it's in the second position within the arguments, and so it spits it out of the second outlet and so on. So, just as with the drum sequencer that we had before, as counter counts through select, select is spitting out pulses from each of its outlets, or bangs from each of its outlets. In order. But this time, rather than running through a series of gates to establish whether those beats are going to be heard or not heard, and then into a number which would be sent on to whichever drum within general MIDI percussion we wanted, this time we're going through, well, each of those outputs is going through a message box with a number in it. And although, as far as Max is concerned, these are simply numbers, as far as the AU MIDI synth, which is what we're communicating with, there you go. So the output is being directed to the audio unit DLS synth on my Mac and would be sent to something equivalent on a PC. When this receives numbers, it recognises those as being pitches. So those numbers go through MakeNote object to make notes of a particular duration, in this case 200 milliseconds, and then into the internal MIDI synth on my Mac. So if I, well, the patch is locked, so we turn that on, and it runs through that sequence of notes. So just a reminder that this note here is 60, and 60 is always middle C in MIDI language. And then 4 semitones above that is the note E, and 3 semitones above that would be a G, 72 would be another C, 76 an E, 79 a G, and so on. So that's why we get that arpeggio. So if we move on to the next page, we're invited to replace the counter object here with a random object. So counter is a number generator in Max, which means that every time it receives a pulse from the metro, it generates a count, or it generates a number, but that number is based on what we're asking it to do, which is to count. So there are other number generators in Max, one of which is a random object, and we'll look at this more in due course, but just for now, just to introduce it, if I change this counter object to a random object and put in the argument of 8, then random will, whenever it receives a pulse, it will output a random number, and it has 8 to choose from. But just as with the counter object we were looking at, where we start counting at 0, the random object also considers 0 to be a number. So it will produce 8 random numbers, but they start at 0. So they will be 0, 1, 2, 3, 4, 5, 6, and 7. So that's something to remember with the random object, is that the argument that's in there will never actually appear, or the number that's put in as an argument will never actually appear. It's always one below that. But beyond that, it does exactly what you might expect it to do, and produces a bunch of random numbers, which once again, when sent to select recognises the number and then spits a bang out of the outlet that's associated with its position within the arguments, and you get that random quality. So that's just to introduce the object. We'll come back to that in due course. Let's go back to the counter object again. Now, so far we've got a sequence just as we were expecting, but if we were to produce some music with this, we would want that sequence to change at least periodically, otherwise it's going to get very dull. So you'd want to update the numbers in these message boxes. So you can update those. You can make an integer object and send that into the right-hand inlet of the message box. Lock the patch, and then if I change that, then you can see the number is updating within this message box. And we could make that 61, for example. So turn that on, and it's done what we want it to do. It's played a different note. You might ask, well, why always have it running through a message box? Why not just have an integer box down there which you can change? It makes it much easier to change those numbers whenever I want to. Well, let's try that, just to show why it's not so ideal. I'll have to make it a bit smaller so that it doesn't interfere with the rest of the patch. So this, if I change this to 60, well, you hear the problem immediately. But if I turn on the metro again, then we're still getting that arpeggio, which is fine. The problem is if I change it, we always hear the note. So what we want is a storage device that will store that number without outputting it immediately when we change it. Hence the message box. So you notice that if I undo all of that, go back to the message box, then you see that when I update this integer box, this number changes within the message box, but doesn't produce any output. So that's the reason for that. But like I say, yes, you want these to change, but having to do them all independently, so that would require me adding an integer box to each of these message boxes, is going to be long and laborious, and you wouldn't be able to change them in short order as you'd probably want to. So we have a way of doing that, which, if we move on to the next page, is what is being done with these message boxes up here. So I've already drawn that out. So basically this is exactly the same patch, but with a few additional bits and pieces which are in orange. So here we've got a message box again. So this is a message box, these are message boxes, but obviously you can see that in these ones there are lots of numbers in the message box rather than just one. And these again, they're just numbers as far as Max is concerned, but we are considering these as being the pitches we want in our sequence. And what we want to do is, well, conveniently there are 8 numbers in there, and there are 8 pitches that we want to play in our sequence. So what we want to do is to get these numbers to be split out from this single message box into the 8 separate message boxes, and they're so that counter can count through them. And we use the unpack object for that. So this is just an object that will split up lists of numbers into individual messages. And you can see that as arguments I've got a series of 8 zeros in there, and those 8 zeros simply are kind of placeholders for the outputs that we want. So if I put in 8 arguments of 0, then I get 8 outputs. So I lock the patch, and when I click on these message boxes, those values get updated in the message boxes down here. so that all works fine. And when I turn on the metro, you hear that we've got the first few bars of a Bach Prelude. But for a start, they're in a slightly strange order, you might think. And if I wanted them to play in the correct order, I would have to listen very carefully and hit the buttons at the right time. And then I'd have to go back to this one. If I get it wrong, or if I press any of these buttons at the wrong time, then you can hear that the kind of sequence gets muddled up. Let's turn that off. And that's because, of course, the metro is relentlessly counting through its sequence of 7 beats, but whenever I click these, the numbers are being sent immediately. So even if a counter is halfway through a sequence, the numbers will be updated, and therefore the sequence gets a little bit jumbled. So what we really want is a way of triggering these message boxes at the right time so that they update these message boxes and we get the correct sequence at the right time. So the next bit of the exercises was to invite you to do that. I think this is just explanation in here. Yes. So I ask you to copy this routine, but I'm actually going to do it bit by bit for the purposes of this tutorial because it explains why it is as it is. So I'm going to make that a little bit smaller so that we can see. Unlock the patch. Right, so basically what we want is for these message boxes to be sent, or for the sequence to be updated at the beginning of every bar. So obviously we need these number boxes to be told to change before they actually play, before the whole kind of bar plays. So for that we need to recognise the beginning of a bar. Well, we know from counter that the beginning of the bar is the number 0. So let's put in a select 0 object up here. Whoops. And connect the counter to it. That means that we get a flag every time counter reaches the number 0. So you can see that that's happening. And then we need to, because we want to play these message boxes or send these message boxes in a particular order, basically we need to count through bars so that we can, at the appropriate bar, we can send a message to these various message boxes to tell them to spit their contents out into these number boxes here, or message boxes here. So we'll use a counter object to count bars. And I'm going to count, because I'm only doing a portion of this prelude, I'm going to count from 0 to 15, so that'll be 16 bars that we'll hear. Oops. And we will show the count for a minute. Unlock the patch. So now it's counting bars, or at least at the moment it's counting groups of 8. So it's doing what we want it to do. And then, like I say, we want to specify, or we want to tell Max that at particular bars we want to get something specific to happen. Well, down here we're using the select object to say when we reach particular beats we want something to happen. So we can use the same mechanism up here to specify that we want something to happen when we get to a particular bar. So we unlock that, drag this down, and there we go. So here we've got a select object that's recognising when we get to particular bars. and then obviously from the outlets it will send a bang when it reaches those bars. So down in the instructions we've got a list of the order of events within the prelude. So like I say, we've got two iterations of the first bar, 2 iterations of the second bar, 2 iterations of the third bar, and then it goes back to the first bar again, and then it carries on with other stuff. So we want to say, well, in the first bar we want this sequence to play. In the next bar we want the same sequence to play because it repeats. The next one we want a different sequence to play, and that repeats. And then a different sequence to play, and that one repeats. And then we go back to the first one again. And then on with the others. I'm going to do it in a different order because it's quicker. There we go. And that should work. We're in the middle of a sequence now, but you'll hear that it catches up and plays the right thing now. So the sequence now plays in order. So the message really there, I mean there are much better ways of implementing a sequence in Max, and we'll come to those in a future tutorial. We'll look at tables and cols and things like that, particular objects that allow you to kind of draw in pitches rather than having to write them in like that. But this is to show you that you can get Max to do useful things with a very limited set of objects. So we just looked at the metro, the counter, and the select object, and we've repeated those. And yet we have two levels of structure here. We've got things going on the beat level, and we've also got things going on the bar level. So yeah, you can get Max to do quite complex things potentially with quite limited range of objects.